Bismillahirrahmanirrahim. Today we are going to speak about the continuity of a function. In the last two sections, we spoke about the limit of the function. The first one was limit at finite number, and the second topic was limit or finding the limit of a function at infinity. Today we are going to speak about the continuity of a function. What do we mean by continuous function? The continuity of a function means that if we think about the graph of the function, you see it is like a curve in one time without jumping, without breakdown, without anything. There is no gap in anywhere in the domain of the function. So it is like just one piece of the function, this one piece over certain domain. So we say that the function is continuous if the curve of the function has no jump, no discontinuity. This is just informal definition. But the formal definition for the continuity of a function, we say that a function is defined or is a continuous a function if it's said to be continuous at a given point at x equal c if the following conditions are satisfied. One, f of c is defined. The first condition that f of c is defined, it means that the function f has a value at the given point, mean it is not infinity. When we see defined, means we have finite value. So this is the first condition. The function is defined at the given point c. Second condition, limit of the function f of x as x goes to c exists. The limit exists. Third condition, that f of c is equal to the limit of the function where x goes to c. So these are three conditions for a function to be continuous at a given point c. Now let's see, or let's explain these three conditions with different type of examples. Example number 1. Discuss the continuity of f of x at x equal to 2. So that's example number 1. F of x equal to x minus 3 divided by x squared minus 4. I need to check whether this function is continuous at x equal to 2 or not. It means I need to check the three conditions. Are they satisfied at x equal to 2 or not? If one of the three conditions is not satisfied, means the function is not continuous. So in the first condition, let's find f of 2. x equal to 2, the first condition said that f of c is defined. So let's find the value of the function at x equal to 2. Replace x by 2. So I will have 2x or 2 multiplied by 2 minus 3 divided by 4 minus 4. That is 4 minus 3 over 0. And as you know that dividing by 0 is not defined. Be careful about this point. We are speaking about the value of the function, not the limit. If the limit x goes to some number, that will give me some 0 over 0 in some cases, that is the limit. We need to simplify it, but this condition says that we need to find the value of the function, not the limit. So minus 1 or 1 over 0 is undefined. This is 1 over 0, which is undefined. And this is violating the first condition. So the first condition is not satisfied. Then no need to check the second or the third condition. So since the first condition is not satisfied, we say that the function is not continuous at x equal to 2. So f of x is not continuous at x equal to 2. Let's take another example. Number 2. See that f of x equal to, use the same function, 2x minus 3 over x squared minus 4. For example, x equal to, or let me choose 4 up. X squared minus 4, where this is if x is not equal to 2 and is equal to 3 if x equal to 2. I have piecewise function, and I need to check whether this function is continuous or not continuous. So I have to check the 3 conditions. The first condition, I need to check f of 2. What is the value of the function when x equal to 2? F of 2 means x equal to 2. So when x equal to 2, if x equal to 2, the value of the function is equal to 3. So this is defined. So the first condition is satisfied. Now let me check the second condition. The limit, is it exist or not? So the second condition, which is B, limit of f of x as x goes to 2. And we said before that x goes to 2 means x is not equal to 2. This is the meaning of x goes to 2. It is approaching the number 2, but it is not equal to 2. So it means that we are going to use the first part where x is not equal to 2. So this is equal to limit of the function 2x minus 4 divided by x squared minus 4, where x goes to 2. Now we have rational function. For the rational function, I need to check whether it is 0 over 0 or non-zero over 0 or whatever. So first step, I will substitute, replace x by 2. I will have just not equal. Let me check first. This is 2 multiplied by 2 minus 4 divided by 4 minus 4, which is equal to 0 over 0, which means I have to simplify to find the limit. We need to simplify. Let's simplify this function. So I will have limit of take 2 as a common factor. From the numerator I will have x minus 2, and down it will be x minus 2 multiplied by x plus 2, where x goes to 2. Now we have common factor, that is x minus 2 with x minus 2. So the limit will be 2 over x plus 2, where x goes to 2, and this will give me 2 over 4, which is equal to 1 over 2. Now the limit exists, which is okay. So the second condition is satisfied. First condition, the function is defined at x equal to 2. Second condition, the limit exists. Now we need to check the third condition. Third condition, f of 2 is equal to, we found it up, is equal to 3. Limit of the function where x goes to 2 is equal to 1 over 2. And you can see these are not equal. It means the third condition is not satisfied. Since the third condition is not satisfied, this is not satisfied. It means f of x is not continuous at x equal to 2. So the function is not continuous when x equal to 2. So this is the idea of the continuity of a function. We have 3 conditions must be satisfied. First condition, f of c is defined. It means has a finite value. Second condition, the limit exists. Third condition, the value of the function at the given point is equal to the limit. If they are not equal, then the function is not continuous at that point. Third example, let's say that f of x 2x minus 1, if x greater than or equal to 3, or because we have to go to 2, and it is x squared plus 4x minus 1 if x is less than 2. Let's take this one. Is it continuous at x equal to 2 or not? So all what we need to check the 3 conditions. First condition, f of 2. Now f of 2 means x equal to 2, and this is x greater than or equal to 2, means we are using the first part. It will be 2 multiplied by 2 minus 1, which is equal to 3. 4 minus 1 is equal to 3. Now second part, I need to check the limit. But since we have x greater than 2 and smaller than 2, it means I need to check the 2 limits, the 2 sides, the right limit and left limit in this case. So I need to find the left limit, x goes to 2 minus, and right limit, 2 plus. Now when x goes to 2 minus means less than 2, which is this one. This is less than 2. X goes to 2 minus means x is less than 2. So the left limit is using the polynomial x squared plus 4x minus 1. We are using this part because x is less than 2. Replace x by 2. I will have 4 plus 4 multiplied by 2 is 8, minus 1, 12 minus 1 is equal to 11. So the left limit is equal to 11. Now the right limit. Right limit means x greater than 2. This is x goes to 2 plus. Right limit greater than 2. it is 2x minus 1, which is equal to 2 multiplied by 2 minus 1 is equal to 3. Now you can see the right limit f of x as x goes to 2 plus, which is equal to 3, is not equal to the left limit as x goes to 2 minus, which means, this means limit of the function x goes to 2 does not exist. So the second condition is not satisfied. Second condition is not satisfied, which means the function f of x is not continuous at x equal to 2. So the function f of x is not continuous at x equal to 2. Now, based on what we have now, I will write remark. For the discontinuity of a function, we have different types. If f of c is not equal to the limit of the function, like the second example. Suppose that f of c is defined and the limit exists, but the limit is not equal to f of c. We call this is jump discontinuity. Then we have jump discontinuity. Sorry, not jump, removable. This is removable. Got it again. Because this is removable discontinuity. Removable discontinuity means if the graph of the function at C, we have open home. So the limit from the left equal the limit from the right, the limit exists, but the value of the function, which is f of c, will be somewhere not equal to the limit. And because this is removable, which means that if we can put a value that equal to the limit of the function, then I will have continuous function. So this is the first type, removable discontinuity. Second type, if limit of f of x, x goes to c, does not exist. Which means that limit of f of x as x goes to c plus or minus is not, the left limit is not equal to the right limit. Then we have, we call it jump discontinuity. Means I have, this is C, some value to the left of the C, and the right one, I will have jump, it will go somewhere to the right. So we have gap. It should be somewhere. So we have gap between the left limit and right limit. To move from the left side to right side, we have to jump to go over that gap. So we call it jump discontinuity. theorem. The polynomials are continuous everywhere. Number one. Are continuous everywhere. Everywhere. It means that if we have a polynomial, then at any given point from minus infinity to infinity, the three conditions will be satisfied. The three conditions are satisfied for any point on the real line from minus infinity to plus infinity. For the rational functions, number two, are continuous except at the zeros of the denominator. So we say if we have a rational function, then it is continuous except at the zero of the denominator.